This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Let's take a look at factoring polynomials. Here's our first example. We'll factor 18m cubed minus 9m squared plus 4m minus 2. This is a cubic function with 4 terms. These can sometimes be difficult to factor by hand, but I notice a pattern here. 9 is half of 18 and 2 is half of 4, so we might be able to factor by grouping. Let's try it. We'll group these first 2 terms and these second 2 terms, and we'll take out the greatest common factor from each group. Let's factor 9m squared from this first group, which leaves us with 2m minus 1 inside the parentheses here. We can take out a 2 from the second group, which leaves us with 2m minus 1 on the inside. Notice how the expressions inside both sets of parentheses match, so we can factor out 2m minus 1, and we're left with 2m minus 1 times 9m squared plus 2. This can't be factored any further, so this is our final answer. Let's check our work by multiplying these out. 2m times 9m squared is 18m cubed, 2m times 2 is 4m, negative 1 times 9m squared is negative 9m squared, and negative 1 times 2 is negative 2. Rearranging the terms, we get the expression we were given originally, so our answer is correct. Remember that you can always check your factorization by multiplying and comparing with the original polynomial. Nice work. Let's try another example. Let's factor 4x cubed minus 2x squared minus 30x. The first thing we can notice about this polynomial is that each term shares a common factor of 2x. So let's start by factoring that out. We get 2x times 2x squared minus x minus 15. This expression inside the parentheses is a quadratic where the leading coefficient is not equal to 1. So we will want to split up our middle term and then factor by grouping. But how do we split up our middle term? Well, we'll want to rewrite the quadratic expression as ax squared plus r1x plus r2x plus c, where r1 times r2 equals a times c and r1 plus r2 equals b. Let's go through the process step by step. First, we'll multiply a and c, or 2 and negative 15, to get negative 30. Let's list the factors of negative 30. We have 1 and negative 30, 2 and negative 15, 3 and negative 10, 5 and negative 6, and then all of these same factors, but with the negative and positive reversed. Now, we're looking for factors of AC that sum to b, which is negative 1. Which of these factor pairs add to negative 1? That's right, negative 6 and positive 5. Let's rewrite our quadratic as 2x squared minus 6x plus 5x minus 15. Now, we'll factor by grouping the first 2 terms and the last 2 terms. The first 2 terms have a common factor of 2x, and the second 2 terms have a common factor of 5. Notice that the expressions inside these parentheses match, so we can factor that out and we end up with 2x plus 5 times x minus 3. Don't forget that 2x in the front that we factored at the beginning, so our final answer is 2x times 2x plus 5 times x minus 3. This looks great. Here's our next example. Let's factor x to the 4th minus 5x squared plus 4. This polynomial has degree 4, which can seem a little daunting, but you might notice a pattern here. The degree of each term is counting down by 2, and the expression kind of resembles a quadratic in standard form. Well, we can rewrite this expression as a quadratic to help us solve. We are going to assign a variable u to equal x squared. What this allows us to do is rewrite everything in terms of u, which will reduce the degree of each term so that it looks like a quadratic. Remember that x to the 4th is equal to x squared squared, so this expression can be rewritten as u squared minus 5u plus 4. This looks much more manageable for factoring. This factors to u minus 4 times u minus 1. Now that we have our factors, let's put x squared back in for u. Notice that x squared minus 4 is a difference of squares, so we can break that factor down even further as x minus 2 times x plus 2. The same goes for x squared minus 1. It factors as x minus 1 times x plus 1. So our final answer is x minus 2 times x plus 2 times x minus 1 times x plus 1. Nice job here! Let's look at another example. 9x squared plus 30x plus 25 is a quadratic expression with a leading coefficient not equal to 1. So we could use the same process from earlier, where we rewrite the expression by splitting the middle term and then factor by grouping. But this expression follows a special pattern, so there is another way we can factor it. Squaring the binomial a plus b gives a squared plus 2ab plus b squared. We can rewrite 9x squared plus 30x plus 25 as 3x squared plus 2 times 3x times 5 plus 5 squared. So this is a perfect square trinomial. Using the formula, we can factor to 3x plus 5 squared. Perfect! Let's try one more. Here's our last example. We'll factor the expression 125w cubed minus 27. You might notice that 125 is equal to 5 cubed, w is cubed, and 27 is equal to 3 cubed. This polynomial expression is following a pattern called difference of cubes. Difference of cubes can be factored using this formula. So let's start by rewriting our equation as 5w cubed minus 3 cubed. Okay, now we'll use the formula and get 5w minus 3 times 5w squared plus 5w times 3 plus 3 squared. Let's simplify that second set of parentheses to get 25w squared plus 15w plus 9. This doesn't factor any further, so this is our final answer. Great work on these! You're ready to practice factoring polynomials on your own.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.